Good morning, all. I welcome you for the lecture series in the course Basic Civil and Mechanical Engineering. You could see a picture here where flames are coming out of this projection. So, can you guess what is this equipment is for? Yes, there is a molten metal rushing out through this opening, and there is a flame here in the top. It is, of course, a furnace to melt metals, right? So the conventionally used metals, melting metal furnaces are cupola furnace and blast furnace. Let us see what is cupola furnace in detail in this class. So cupola is a cylindrical in shape and placed vertical. Its shell is made up of steel. Its size is expressed in diameters and can range from 0.5 to 4 meters diameter. Internal walls are lined with refractory bricks. So these are the parts of cupola furnace. We have a spark arrestor in the top of the thing, and we have a charging door here. We have a stack zone here, and we have a steel shell in both the sides, refractory lining, and there is an air box. There is a ready. We have different types of zones that we will discuss in the next slides. We have an air blast inlet, and we have tires and pedaling zone, and we have legs to withstand all the load, and we have sand bottom and slag bottom, and we have a tapping hole where the molten metal is being collected, and the number 1, 2, 3 is nothing but coke, flux, and metal. In this kind of combination, it is being arranged inside a cupola furnace. So what are the different zones we have? We'll discuss one by one. The space between bottom and tires and the sand bed, molten metal collected in this portion, we call it as well, because the molten metal is collected here. So we have a combustion zone. In this zone, the temperatures are all around about 1540 degrees centigrade to 1870 degrees centigrade. The exothermic reactions takes place in this zone. Carbon plus oxygen combines to form CO2 plus heat, and this heat is utilized in melting the metals. And the reduction zone, it is located between the upper level of combustion zone and upper level of coke bed. So in this zone, the temperature is all around 1200 degrees centigrade. In this zone, carbon dioxide change into carbon monoxide with combining with coke. So the next zone is melting zone. In this zone, the melting is done. It is located between preheating zone and combustion zone. The following reaction takes place in this zone. Iron combines with carbon monoxide to become iron oxide plus carbon dioxide. Okay. We'll repeat once again this equation. Iron combines with carbon monoxide to give ferric carbide or ferrous carbide, we call it as, and carbon dioxide. The next zone is preheating zone. This zone starts from the upper end of the melting zone and continues up to the bottom level of the charging door. Objective of this zone is preheat the charges from room temperature to about 1090 degrees centigrade before entering the melt charge to the melting zone. The next part is stack, the empty portion of the cupola above preheating zone. It is called a stack. It provides passage of hot gases to go to the atmosphere from the cupola furnace. So working principle, its charge consists of scrap, coke, and flux. The charge is placed layer by layer. The first layer is coke, second layer is flux, and third layer is metal. Air enters through the bottom tires. This increases the energy efficiency of the furnace. Coke is consumed, and a detailed video is given how this cupola furnace works. Let us watch and then understand things. So we come to the second part of the furnace, that is blast furnace. So it's a tall cylindrical furnace made of steel. It is lined inside with fire bricks. It is narrow at the top and has an arrangement for the introduction of ore and outlet for waste gases, heated with the help of hot gases. So the functions of a blast furnace is to reduce and convert iron oxides into uh, lightweight metals called hot metal, liquid metal. The blast furnace is huge steel stack lined with refractory brick. Iron core and coke limestone are put into the top and preheated air is blown into the bottom. So this is the blast furnace that will look like, where we have a molten slag at the bottom. Blast air in and out is given, and carbon monoxide forms and rises at 1800 degrees centigrade. Iron forms and trickles down at 400 degrees centigrade. Carbon dioxide forms and rises at 1400 degrees centigrade. Waste gases out uses to heat up the air blast, and here with the waste gases out, a hopper for loading charge, new charge added here. So due to gravity, all the molten metal is collected at the plug hole. So important reaction that takes place in the blast furnace is oxygen in the air reacts with coke to give carbon dioxide. The limestone breaks down to form carbon dioxide. Carbon dioxide produces 1 plus 2 react with more coke to produce carbon monoxide. So we have a small video to understand what is blast furnace. I hope you all understood what are the two types of furnaces basically used in foundry process. Thank you for your patient listening. We'll see in the next lecture series. Thank you all.